we're starting to put those log laws together, so now we're going to have to use all three at once. And we are going to, let's see where we're going to skip to here. We're going to go to class example 2. So class example 2 says, use laws of logarithms to write 1/2 log base a of 16 minus 1/3 log base a of 8 as a single logarithm. So remember, we cannot combine these things using division until there's no numbers out front. So as it is, we cannot combine it to be division because of this 1/2 and 1/3. Now in the one example we did earlier, we could factor out a 3 because they both had a 3. Now they have different numbers, so we can't just factor something out, but thankfully we have the power law. So we can write this as log base a of 16. That 1/2 can become an exponent, minus log base a of 8, and now the 1/3 can become an exponent. Remember that an exponent of 1/2 really means the square root, so this is log base a of 4. Minus an exponent of 1/3 is really a cube root, so this is log base a of 2. Now we're ready to write this as one logarithm because there's no numbers out front anymore. So now this becomes log base a of 4 over 2, which is log base a of 2. So we're going to do similar things here. 3 log x minus log x cubed. Well, we can think of it in two ways. One way we can say, I'm going to move the 3 up. And now I have log of x cubed minus log of x cubed, which is 0. Alternatively, you could have moved this 3 out front, and you would have ended up with 0 as well. Next one, 2 log 5 and 2 log 2. So same thing, if we make these exponents, this becomes log of 5 squared plus log of 2 squared, which is the log of 25 plus the log of 4. These are being added, so to bring them together in one logarithm, we would multiply the arguments. So this is log of 100. 10 to the power of what is 100? 2. So that evaluates to simply be 2. Now, of course, on your calculators, you can do that evaluation without your log laws, but it becomes more important when there's variables involved. Next one, so this one, kind of hard to evaluate like this. So we can split it into 2 separate logarithms. We need to subtract them because there was division here. So we can make it that. Now we can bring those exponents out front. Sorry, that should be of 81. And now we can start evaluating things. Log base 3 of 27 is 3. Log base 3 of 81 is 4. So this really becomes 9 minus 16, which is equal to, whoops, sorry, not -5, -7. Okay, if log base 2 of x equals a, determine the expression for log base 2 of 16x squared. So the first thing we need to recognize, this is a product here. We need to be careful. We need to be careful that this exponent of 2 is not applying to the whole input. It's not applying to the 16, so we can't bring it up front yet. We need to first separate this into 2. So this can be log base 2 of 16 plus log base 2 of x squared. This we can evaluate. Log base 2 of 16 is 4. Log base 2 of x squared, well now I can bring the 2 out front if I want. And I would get this. Now you see it told me here log base 2 of x is a, so this is really then 4 plus 2a. Example 5, write the following expression as a single logarithm. So the very first thing we want to do with questions like this, we need to deal with these two numbers out front before we can bring things together. So I can write this as log b plus log d minus log e to the power of 5 minus log a squared plus log a to the 1/2. Now to bring things together. So anything that has a plus, the inputs are going to go on top of a fraction in our argument. So log of b times d times a to the 1/2. Those are all things that were positive. Things that are negative now, change color here, are this and this. Those are negative, so those go on the bottom. So e5 a squared goes on the bottom. And now, just to simplify our exponents. Whoops. To simplify our exponents, so b and d stay up here. This is going to leave me with a to the 3/2 on the bottom, subtracting the exponents, and e to the 5. We usually write these in alphabetical order once you're doing this, but I mean, it really doesn't matter.